This one gets me periodically if I'm not paying attention. Because I go down through and it's easy, what's the domain? Well, the denominator can't be 0. So that says it's all real numbers. X can't be, that's a positive 6. X can't be negative 6. My automatic reaction is to say that x equal negative 6 is a VA. Now, in this class, you can be fairly automatic. But in calculus, basically, you can go either way on you. Now, there are two things I can do. One is put negative 6 in the numerator. If it makes the numerator 0, that means that x plus 6 is a factor of the numerator. So I would look at negative 6 squared plus a minus 6 minus 30, which is 36 minus 6 minus 30, which is 0. Now, since I have 0, the remainder theorem basically then says that this guy, x equals 6, is a 0, or x minus 6 is a factor. So that means that x squared plus x minus 30 factors into, so this guy is actually equal to x minus 6 times x plus 5 all over x minus 6. This creates the hole in the graph. So what he really is x plus 5, where x can't be, this should be, I'm wrong, this is a plus. This makes that a minus, wasn't paying attention. So it's x minus 5. And x can't be negative 6. And what's there? There's a hole at negative 6. There's a hole at x equal negative 6. So vertical asymptotes, there's none. Now, what about end behavior? Well, if I'm looking at y equal x minus 5, where x can't be negative 6, there is no end behavior asymptote. You don't have an OA, you don't have an HA. You don't even have a VA. Now, if I want to take a look then at the graph, I'm going to be graphing y equals x minus 5, where x can't be negative 6. Now, that means I'm going to have to scale my graph paper, or do I have enough? 1, 2, 3, 4, 5, 6. I'm okay. So I've got my graph paper chosen correctly. Well, let's go after the x-intercepts. Well, that's where y equals 0, or x minus 5 equals 0, or x equals 5. So it's going to be 5, 0. And the y-intercept is where x equals 0. So that means that y equals 0 minus 5, or y equals minus 5. So it's 0 minus 5. So I've got 5, 0, 1, 2, 3, 4, 5. And I have 0 minus 5, 1, 2, 3, 4, 5. And I could draw a line in between, but I've got to put something else into play. There is a hole at x equal negative 6. So if x equals negative 6, I'd have that y equals negative 6 minus 5, which is minus 11. So minus 6 minus 11 is a hole in the graph. So let's see. 1, 2, 3, 4, 5, 6, 7. This guy's going to go down further. This is always the problem with these guys. 7, 8, 9, 10, 11. So negative 6, 1, 2, 3, 4, 5, 6, negative 11, there's a hole right here. And then I connect the dots. He's just a straight line with a hole in him.
So how would you catch that normally, though?
Before it catches you.
You always want to factor the top? Or
Yeah, try to factor the top. What you want to be interested in is once you know what the factors of the bottom are, you put those values in for x in the top. If it makes the top 0, one of those things divide out. Because you'll get a 0 over 0 form. The big key in calculus for us always is we look for a 0 over 0 form. That means the numerator and denominator have common factors. And then we factor it and reduce. Now I'm going to see if I can get a graph of this sucker up. So I'm going to do a zoom standard, zoom 6. It's not going to hit there. And then I'm going to try to enlarge this window. The X's are fine, it's the Y's. Let me double the Y's and see if we can pick it up. If I were to say now, evaluate at x equal negative 6, notice there's no y value there. That's because there's a hole in the graph. Now the question is whether or not I will be able to see the hole. You have to kind of almost know what you're doing. I'm going to do a zoom decimal. Now zoom decimal gives me nice numbers. And now I'm going to mess with the window. X's need to be out too, so I'm going to double the X's. Y's, I need a negative 11, right? So we know it's down around negative 11, so I'm going to take 4 times the Y's. There it is. Barely see it. So I'm going to zoom in, zoom 2, and see if I can go after it. It's negative 6. And let's see if that'll bring it up. And even then you can barely see it. It's right there. It's right there where my cursor is. There's a break in the graph. It's so minute. And even then, I've now lost it. So I'm going to do zoom previous. I'm going to go back. So there it is, and I'm going to shut